Hi friends, and welcome to another fun video. In this tutorial, we're going to create a face-based carbon tape or carbon fiber wrap as displayed here. This tape reinforces existing structures like beams, columns, slabs and bridges, increasing their load bearing capacity. And since this tape is usually applied on the surface of other construction, I will make it as a face-based family, meaning it can be hosted on the face of another element within a project. This flexibility allows the family to be placed on any surface, such as walls, floors, ceilings, roofs, or even other families. Alright, I have opened up a fresh face-based family template that contains some built-in parameters. Go to the front view and start placing out some reference planes using the hotkey RP. These planes will be used to hold the geometry, and it is crucial to create a parametric family. Now, I use the dimension line tool with hotkey DI. Press the EQ sign, meaning I want an equal distance between the reference planes and the center line. Dimension line for the thickness. Be sure to not mark the object but the reference plane to the reference plane. Go to plan view and annotate what will be the length. Time to set up the parameters for our family. Is it not that many? I will start with the material parameter, which needs the data type set to material and finishes. So, the thickness, I will set it as a type parameter. I made a whole video on the difference between type and instance parameters. Click the link. The width will also be type based, and the final parameter will be the length. This one, on the other hand, I will set as an instance since the length may vary from each instance in the project. A handy tip: you can move the parameters up and down. I suggest putting the most used parameters at the top. Now I need to connect the newly created parameters with the dimension lines. Select a dimension line, go to the menu bar and select the correct parameter from the drop-down menu. Change the numerical values to some more realistic carbon tape values and do some cleanup, moving the parameters closer. I will also change the scale. The text will become bigger or smaller depending on the scale change. Looks a little bit better. I almost forgot to connect the length parameter. Let us set the thickness to 10 millimeters, making it a bit easier to place out the geometry, which is our next step. The tool I will use is the Extrusion tool. Draw the 2D profile in the front view, which is just a rectangle, then align the geometry to the reference planes. Hotkey for the Align tool is AL. To align, press the hotkey, select the reference plane, and then select the edge of the geometry, and remember to lock it by pressing the tiny padlock. I will go ahead and change the numerical parameter values to check if everything works as intended. This operation is called flexing, and I would recommend doing it regularly when developing a complex family, so you don't end up at the end with a highly advanced family that don't work. Gonna be a nightmare to find the errors. Forgot to constrain the length of the geometry. Quickly do that. I would also like to connect the material parameter to the object. Select the element, go to the properties menu and press the tiny button to select the material parameter. Although I have connected the material to a parameter, giving the user in the main Revit project the option to change it without opening the family. I want to add default material to the Revit family so the end user does not have to do it. The material here will be carbon. Sadly, it does not exist in the Revit material library, so we'll just use titanium and make some changes to it. Right-click the material and rename it to carbon and add the letters CFRP, that stands for carbon fiber, reinforced thermoplastic. I could add a more careful description, but let's just go for carbon here as well to keep this tutorial short and sweet. Nothing more here. Move over to the graphics header. The default here is gray. The carbon has a more black color, but not completely black. I think that's good. We'll also need to change the color and roughness under appearance. Alright, all done with the material. The end user can change the material if he or she wants, but will not have to change it because I have already defined it. Last step before loading it into the main project. Do a quick purge, removing all unused objects, and then I load it into the main project. Since this is a face-based family, I have the option to either place it on a work plane I can change like I'm showing now. Let's try to pick a new work plane. I would like it to be on the top of the wall the work plane is now showing. To place out my family again, I go to the project browser and find the carbon tape family, which is categorized as a generic family, and just drag it out. But the big benefit for face-based families is it can be placed on any face, meaning it can be hosted on the face of another element within a project. I have opened up a plan view where I can see my carbon tape. The neat thing here, since the length parameter is an instance parameter, is that I can drag the family out with the handles showing on the edges. To show its flexibility, I would now place the carbon tape on the wall. I once again find my family in the project browser and drag it out and just place it on the concrete wall. Simple as that, the power of a face-based family. This flexibility is just what I want with this carbon tape family, since it will always be placed on another construction to reinforce existing structures. The final step is to create two distinct types that align with the manufacturer's specifications, one with a width of 200 and another with a width of 100. This approach works because the width parameter is defined as a type parameter. As a result, I can easily switch between the 100 width carbon tape and the 200 width carbon tape. And that concludes this tutorial. Be sure to like and subscribe for more fun videos.